Hey everyone, we're going to talk about a word you probably use every day, theory. But I'm willing to bet you're not using it the way a scientist would. So let's get into what a scientific theory really is.
All right, so let me ask you straight up. What pops into your head when you hear the word theory? Like, is it just a hunch, some wild guess? Hold on to that thought.
And right there, that's where all the confusion comes from. See, for most of us, a theory is, well, it's just a guess, right? An assumption. But in the world of science, it's the exact opposite. A scientific theory is a rock-solid explanation for why things are the way they are, something that's been tested over and over and over again. To really get what this means, we're going to dive into a couple of incredible stories.
Okay, first, let's jump in our time machine. We're going way back to look at an idea that was, and I mean this literally, over 2,000 years ahead of its time. This is the story of the atom.
So picture this. It's about 400 BCE. The smartest people on the planet, guys like Plato, had a pretty simple view of the world. They believed everything, and I mean everything, was made of just four basic things: fire, water, air, and, well, soil or earth. That was it. That was the accepted truth. But there was this one guy, a philosopher named Democritus, who wasn't really buying it. He had this completely wild, out-there idea. He said, no. What if you keep cutting something in half? Eventually, you'll get to a piece so tiny, you just can't cut it anymore. He called this tiny, uncuttable particle atomos, which is just Greek for indivisible. Yep, he basically came up with the atom.
And here's the part that just blows my mind. Democritus floats this idea around 400 BCE, but Plato, who is way more famous, just shoots it down. And then, nothing, just silence. For over 2 millennia, the idea of the atom is basically lost to history. It's not until 1808, that a chemist named John Dalton finally comes up with the first real scientific evidence.
Let that sink in. 2,200 years. That is how long this incredible, game-changing idea sat on a shelf, totally rejected by the establishment, all because there wasn't hard proof yet.
So how did Dalton crack the case? Well, he was learning experiments with gases, and he figured out that elements always combine in these clean, predictable whole number ratios. That was the smoking gun. You see, that perfect math could only work if stuff was made of tiny, distinct building blocks, atoms. After 2 millennia, Democritus was finally proven right.
All right, story number 2, and you're going to see a pattern here. This one's about a world that's literally adrift, and another genius who got laughed at for seeing something everyone else missed. Let's talk about the crazy case of the moving continents.
Okay, so fast forward to 1912. The scientific community was rock solid on this one point. The continents do not move, period. The thinking was, the Earth cooled, the continents formed, and that's where they've been ever since. It was considered a basic fact. End of discussion.
But then this German geophysicist Alfred Wegener comes along, and he's not so sure. He starts looking at a world map like a detective looks at a crime scene. His first clue? He sees how the coast of South America fits almost perfectly into the coast of Africa, like 2 giant puzzle pieces. Then he finds identical fossils of this little freshwater reptile on both continents. How does a tiny lizard swim across 4,000 kilometers of saltwater ocean? It doesn't. And for his final clue, he notices that mountain ranges in North America seem to just continue over in Europe, with the same kind of rocks and everything.
So Wegener takes all this evidence, this mountain of clues, and he puts it all together. He proposes what he calls continental drift theory. His idea that all the continents we know today are once mashed together into one giant supercontinent, which he named Pangaea. And then, over millions of years, they broke up and drifted apart.
And you can probably guess what happened next, right? The scientific community basically laughed him off the stage. They called his idea childish, irrational. The problem was, just like Democritus, Wegener had all this great evidence, but he couldn't explain how. What force could possibly be powerful enough to move entire continents? And tragically, he died before anyone ever took him seriously.
But the proof was coming. That missing piece, the how, it finally showed up about 30 years after he died, and you are not going to believe where it came from. Cold War seismometers. Yeah, seriously. These super-sensitive machines were put all over the world to listen for secret nuclear bomb tests. But they started picking up something else, a low, constant rumble. It was the sound of the Earth's tectonic plates grinding against each other. The continents were moving. A technology built for war accidentally proved Wegener right all along.
So you see the pattern, right? These stories show us that a real scientific theory isn't just a neat explanation for something that already happened. No, its real power is in prediction. The ability to say, if this is true, then this will happen. And that is what changes the world. Think about our solar system, for example. For thousands of years, the theory was that Earth was the center of the universe. But it was a terrible theory. Why? Because its predictions were all wrong. It couldn't accurately map out where Mars or Jupiter would be in the sky. But the theory that puts the sun at the center, it works. It works so well, its predictions are so precise that we can launch a tiny metal box from Earth and have it land on a specific spot on Mars millions of miles away. That's predictive power.
And this power is literally all around us. Newton's theory of gravity? It predicted the existence of the planet Neptune before a telescope ever found it. It told astronomers exactly where to look. Einstein's theory of relativity? If we didn't use it to correct the clocks on our GPS satellites, your phone's location would be off by miles within a day. And as we said, the sun-centered model of the solar system gets our rovers to Mars. You see? These aren't just guesses. They're tools. They're like instruction manuals for the universe.
So let's bring it all home. A scientific theory is not just a theory in the way we say it over coffee. It's not a hunch. It's a powerful, predictive explanation for how some part of the universe works. It's been tested, it's been challenged, and it's survived. In science, calling something a theory is one of the highest compliments you can give it.
So, that brings us to maybe the most famous and most misunderstood theory of all. People love to argue about it, right? But now that you know what a real scientific theory is, a powerful, predictive explanation backed by mountains of evidence, it kind of makes you look at that old question a little differently, doesn't it?